on a second. Download this.
For this page, I only need 1 and 2
Okay.
for it, because I understand number 3.
Okay.
Oh, I didn't erase that part.
Okay. There's basically 3 ways to solve a system of equations. There is substitution, there is elimination, and there's graphical.
Mm-hmm.
Wherever these 2 lines cross is the solution. So how would I graph the first line? Y equals x minus 4.
Would you go to -4 and then go up 2, right 1?
Okay. And just to get a little bit more points there. Okay, so that's that line. Now how about x plus 2?
You would go to 2 and then go up 1, right 1.
Yeah, let's go up 2, right 2. The only reason I do that is to give it a little more distance between my 2 points. In other words, if I go up 1 and right 1, I got 2 points that are awfully close together there. It's hard to figure out exactly how to draw it. Now, this is this curve. So the solution lies right there. And this kind of points out one of the problems with this method, which is it's really hard. If I had a straight edge, I'd have probably been able to come up with a better number. But let's assume that that's the number right there. So what is that? 1, 2 over 3, 1, 2, 3, 4, 5. So 3 comma 5. You see where I got that?
Mm-hmm.
Now let's see if that works. It doesn't. All right. It was a good try, but notice that if I plug in 3 for x, I get 6 minus 4. That's not equal to 5.
Yeah.
What's going on here? Sure we did it properly. Why are we getting a solution that's so bad? Let's just figure out what the true solution is, okay?
Okay.
You can always do that by substitution. In other words, if y equals that and y equals that, then the thing on the right side has to equal the other thing on the right side. Like that, okay? Now, if I solve it, I get x equals 6. And then if I plug x in for 6 there, I get y equals 8. Okay? So the true solution was about there. If I would have had a straight edge and been able to do this, that's where the 2 lines would have crossed.
Okay.
Okay? Without a straight edge, it's awful hard to do it. And this isn't really the way you want to come up with any solution anyway. You don't want to come up with a solution that you have to read a graph, because it's too hard to read a graph accurately. Especially when I'm not using a straight edge, when I'm using free drawn lines. Okay? But we know that solution does work into both ones. 2 times 6 is 12, minus 4 is 8. So 6, 8 works there, and 6, 8 works in the second one also. So the solution's definitely 6, 8.
Okay.
I won't say we got it by graphing, but that's only because I can't really lay a straight edge over that. Now, the next one's a little different. The next one, the solution is an area of the graph. So the only way to state the solution is to graph it. Without a graph, there would be no way to define the solution other than those three equations. In other words, I could give the region, well, let's go ahead and graph each of these. How do I graph y is less than minus 2x plus 3?
Do you go to 3 and then go down to right 1?
Uh-huh. In other words, it's a negative slope. Now, do I use a solid line or a dotted line to do that?
Solid.
Yeah, dotted would be if it were less than or greater than, not less than or equal. Whenever you see a less than or equal, it's a solid line. The y is greater than 0, that's going to be a dotted line. Okay? Now, there's my line, but I still have to shade one part of that. Which part do I shade? And always use the words above or below, not left or right. Exactly, below. And what I do is always look to the y-axis. Okay, so I have to find a y point that is less than that line. Well, there's that line. Any point I find on the y-axis is less than that line. So that tells me that's the part I would shade. Okay? Now, it's true, some people might say left, but you don't want to use that terminology. The only time you ever want to say left or right is if it's a vertical line.
Okay.
The next line is a vertical line. Vertical line where x is greater than or equal to negative 2.
So that'd be negative 2 on the x.
Solid line, right?
Yeah.
And this is just a straight vertical line. Now, to figure out which side of this I got to shade, up and down doesn't make sense, so you got to go left or right. But the
right
is most which way?
Right.
Okay. And I'm only interested in the same area. Right? In other words, I'm trying to find the overlapping areas.
Mm-hmm.
Whoops, I screwed up already here. Yeah. No, I didn't. No, that's right. It's greater than minus 2. Okay, now the third one. Y is greater than 0. How does that graph?
Would it be a dotted line on 0?
Which 0? Is it a horizontal line or a vertical line?
Vertical.
It's horizontal. X equal numbers are vertical lines. Y equal numbers are horizontal lines. Horizontal line where?
On a 0?
Yeah, at y equals 0. Well, y equals 0 is the x-axis. Now, which side of that do I shade?
The bottom, I think.
What's that say?
Above, I think.
That means I got to shade above. In other words, what I do is I find a point on the y-axis that is above that line. Well, all of these points are above that line. That tells me which side to shade, always. So if I'm only shading the region of interest, that's what I end up with. And notice that I can't even describe that verbally. I can only give you an answer graphically.
Mm-hmm.
If I were to try to describe the answer verbally, I would have to use these three inequalities. I would have to say x greater than or equal to minus 2, y greater than 0, and y is less than minus 2x plus 3. The only mathematical way to describe this region of interest. Now, let me ask you a few questions here that aren't obvious. Is that point on the area of interest?
Which point?
One I just drew in there, the pink one. Big pink dot.
Yeah.
It's on the black line.
Yes.
Yes, good answer. How about that pink dot?
Yeah, I think.
Uh-huh. How about that pink dot?
Yes.
No. If it is on a dotted line, it is not inside the area. Remember, y has to be greater than 0. Can't be equal to 0. And that dot right there has a y coordinate that's 0.
Okay.
So that doesn't work. So whenever you have a region of interest that's surrounded by solid and dotted lines, you either have to be inside, in other words, that works as long as I'm inside the region, but if I'm on the edge of it, or a vertex, that does not work. That is on my dotted line. That does not work. That is on my dotted line. That works. That is on two solid lines. By working, I mean that point is inside the region that I'm interested in. And you don't always get these kind of questions. Usually they'll give you points that are inside the triangle, and then you can say either yes or no. But occasionally they'll give you points that are on the edge of the region. And then whether it's in the region or not depends on whether it's dotted lines or solid lines.
Okay.
All right. All right. And we want to go to the next page, right?
Actually, I think I sent you the third page. I think it's like the piecewise functions.
Okay, but we don't need to do 3 here, right?
No.
Okay.
It's not that one. I think it's the next one that I sent.
Okay. Since we only have 12 more minutes, you probably ought to get to the piecewise function.
Yeah. Yes, I think.
In fact, we'll go straight to that. I gotta download it. Hold on. Oh, there it is. Couldn't find the download button. Okay, should we go straight to 7?
Yeah.
6 is actually pretty hard.
I understand it.
Okay. You know that you want to make equations 4 and 5, both missing the same variable, and then take equations 4 and 5, come up with a solution for one variable, work your way backwards to solve for the other 2.
Yeah, she said we can use a calculator for it, so it's easier for that.
Okay. Not sure how a calculator would make that easier, but I'll take your word for it. All right. Graph the piecewise function. When you're dealing with piecewise functions, this is the most important thing to consider. These domains over here. These. Okay? There are 2 areas on this graph. One of them is when x is greater than 0, that whole domain all the way out to infinity. And the other one is when x is less than 0. That whole domain all the way out to negative infinity. Okay? That's the first thing to realize. Now, to the right of the y-axis, we're going to graph 2x plus 1. How do I graph that?
Go to 1, then you go up to right 1.
I'm going to go up 1, 2, 3, 4, and right 2, just to give myself a little separation. And notice that that doesn't go left. It stops right there with a solid dot because of this. With me?
Yeah.
Okay. Now let's graph the left side. It's equal to 3 whenever x is less than 0. Well, there's 3 right there. And it's less only, so I have an open dot right there. And that goes all the way that way, just like that goes all the way that way. So basically what you're doing is dividing up the graph vertically based on the domains. And then in each vertical section, you graph the function that is called for.
Okay.
Okay? F equals 3 is just a horizontal line. That's the same as y equals 3. And the other one is a straight line, but with slope. You have any questions on that?
No, I don't think so.
Okay. Let's look at 8. Graph the following function. X minus 4. Well, easiest way to graph this is know what the parent function looks like. What's the parent function?
Just fx, I think.
Absolute value of x, which looks like this. Absolute value functions look like these. Now, to the left of the y-axis, this has a slope of -1. To the right, it has a slope of +1. What kind of adjustment, transformation is taking place between the r function and the parent function? Let's call the parent function g of x, just to distinguish between f of x. Okay, so this is g of x.
Mm-hmm.
What's the consequences of that -4?
It has to be negative on there.
There are 6 kinds of transformations, and I don't know you've had these yet. There's 3 vertical and there's 3 horizontal. These are things like vertical shift, horizontal shift, vertical reflection over the x-axis, horizontal reflection over the y-axis, vertical stretch or shrink, horizontal stretch or shrink. Have you had those?
I don't think so.
Well, I'll tell you, that 4 is a shift, a horizontal shift to the right by 4 units. Well, the key point here is that vertex. So if we move it to the right by 4 units, it goes right there. And it doesn't change the shape of the graph. I'm going to draw our graph this way. Because all it does is takes the exact same graph and moves it over 4 units to the right. Now, people get confused as to which way to go, right or left. How can we tell whether we've done it correctly? What number would you put in for x to check?
I don't know.
When x is 4, what is f of x? Remember, f of x same as y. So in our pink line, what is f of x when x is 4?
4.
What's the y value right there? That's where x is 4. What's the y value?
-4.
0. The y value. Look vertically, up and down, when you're looking at y values. The x value is 4, but the y value is 0. Now, if I plug in 4, do I get 0? Yes, I do. That is equal to 0. So everything checks out. Questions?
No, I don't think so.
All right. Should we just go on to whatever's next, or you need to, you said you can do that one on a calculator. We don't have enough time to do it normally. I'm not quite sure how you can do it on a calculator, to be honest.
She told us to just do the matrix on our calculator.
So you've had matrices.
Yeah.
Which is another way to solve a system of simultaneous equations, is using matrices. And that's actually tougher still, because you got to make your way through augmented matrices or Kramer's rule, one or the other. Which one have you been taught?
I don't know. It's like the second matrix and then...
All right. Well, let's skip that, because, I mean, we could do it, but there's 2 or 3 ways to use matrices to solve that also. Let's see if we can find a 5 or a 10-minute problem here. I got 3 things from you. Which one should I open? The first one had questions 1, 2, and 3, and 4, and we did 1 and 2.
We can...
Is that a picture of you? That's nice. Attractive.
Oh, my mom wanted me to ask you a question.
Okay.
If you tutor for the SAT.
I do. Yes.
Okay. Because we took our practice SAT today.
SAT and ACT.
Okay.
Yeah, I know that kids were taking the PSAT this week. So you took it, huh? PSAT is pretty similar to the SAT. It's not like a beginning SAT. It's just a practice SAT.
Yeah.
Okay. So, yeah, I'd be happy to work with you whenever you want. What year are you in, Haley?
I'm a junior.
Okay. So you're going to take the SATs this fall and then give yourself a chance to take them again in the spring and next fall if you have to, right?
Yeah.
That's the plan?
Mm-hmm.
Okay. Do you know where you're going to college or where you want to go?
Not yet. I think either Metro or Western.
Okay.
I don't know yet, though.
Well, you may get a score on your SAT the first time through that is satisfactory to get into either of those schools. You may not have to take it again. So, but if you do, if you want help when you take it this year, I'm happy to help you with it. Or when you take it next semester or next fall, I can help you with it.
Okay.
Okay. So let's see. Let's look at this middle one again. Yeah, we didn't do anything with this. Let's do something with this in our last 5 minutes here. This was part of your test material, right?
Yeah.
All right. We probably should have started on this one. This is linear programming. This might be the hardest part of Algebra 2.
Okay.
Serious. Why they start you off with it, I don't know. I would never do that to students. I would start off easy and get harder as we went on. But this is about as hard as it gets in Algebra 2. Okay. Now, I can give you a real quick run through on how this works. You want to plot these 3 constraints. Okay? Hold on. Got to remember how to do this every time. These are the constraints you want to plot. Okay? Well, x greater than 0 is a vertical line to the right. So we're going to do that to show which side we're going to shade. y is greater than or equal to 0 is a horizontal line, and I'm going to shade above it because its y is greater than 0. And then x plus y is less than or equal to 3 is a line with a slope of -1 that starts at 3 and has a slope of -1. So our region that we are interested in is that region. That is the only place where x is greater than 0, y is greater than 0, and x plus y is less than 3. Now, the way I would actually graph that one would be to do this. Y is less than or equal to minus x plus 3, and graph that as a line, which is what my slanted line is. And then y is less than that. So I know I have to be below that line. Not left or right of it, but below it. And that puts me in that region there. Okay? Now, the secret to these linear programming problems is to plug in your vertices into the objective function. Well, I have 3 vertices. I have that vertice, I have that vertice, and I have that vertice. Well, if I plug in 0, 0 into the objective function, I get 0. So let's call that the minimum value, which it is, okay? But here's the thing. The minimum and maximum values are always going to be at your vertices. I don't need to check this point right there. I don't need to check an inside point. I don't need to check that point. I need to check these 3 points. That's it. Okay? Well, this vertice is x0, y3. Well, when I plug that into the objective function, I get c equals 3. Well, that's better than 0, right? And when I look at this vertice and I plug it in, that's x equal 3. Well, when x equals 3, c, and y equals 0, c is equal to 12. So I have my minimum value is 0. What's my maximum value?
12.
My vertex, there's 3 of them. There's one at 0, 0. There's another one at 0, 3. And there's a third one at 3, 0. So this really should have said vertices, because there's always multiple vertices in these kind of problems. You never just have a straight line. You always have an area, and that area always has corners. So I can't imagine any shape that didn't have at least 3 vertices. A triangle is going to have 3 vertices. Could be a trapezoid, in which case it has 4 vertices. Oh, I see what's happening here. I didn't read the problem quite right. They want the vertex of the minimum.
Oh, okay.
Well, the vertex of the minimum came at 0, 0. And they want the vertex of the maximum. Well, that's where the maximum came from, was that vertice. When I plug in 3 for x, I get a value of 12. So that would be at 3, 0. And that answers that whole problem.
Okay.
And I'm going to have to run. Ayla, I'm glad we were able to get a session in. I was booked solid all day. I wasn't sure I was going to be able to squeeze a half-hour session in here or not, but looks like I did.
Thank you.
You're welcome. And I'll talk to you next time.
Bye.
Bye-bye.